like this. And we know that the point 3 comma 0 is somewhere here. And they want us to determine a point on the curve. Maybe it's here, maybe it's here, maybe it's here, I don't know. That is the closest to this point. So in this case, I have to minimize the distance. Minimize the distance. Now, the shortest distance, it appears to be here. But I don't care. I'm not going to look for the minimum distance on the graph. I'm just going to say somewhere here. It doesn't matter. I need to determine this distance. And then when I solve and I find the minimum, it will tell me exactly where it should be on the graph. So don't bother with measuring or anything like that. There is no point. There is no need for that. So this is a point on the curve. Let's say it has an x. Can anyone give us the y coordinate of this point? If its x coordinate is x, what is its y coordinate? There is nothing to be thinking about, for us to be thinking about. It's on the graph of the, sorry?
Square root of that.
Right, because it's on the graph of the function, of course. Now, all I need to dig is the distance formula. Anyone remembers the distance formula?
Isn't that the a squared, b squared? Or no?
X2
Square
minus
root
x1,
of,
everything squared, plus y2 minus y1, everything squared. Good. So it doesn't matter which one you consider point 1. It really doesn't matter. So let's say this is point 1 and this is point 2. Can anyone dictate how to write the distance?
Is it going to be open bracket 0 minus?
Yeah, so let's denote this as 1 and 2. So we can say x minus 3 plus
x minus 0.
Exactly, the square root of x minus 0 squared. Awesome. That's it. So then now I know d is a function of x, and this is the square root of x squared minus 6x plus 9 plus x, which is the square root of x squared minus 5x plus 9. I have the distance. Once I have the distance, this is a piece of cake. How do I find the minimum distance? Of course, it's all the same. Find the derivative, find critical numbers, all the same. So the difficult part may be how to find the function, but the rest should be easy. D prime of x, 1 over 2, the square root of x squared minus 5x plus 9, and 2x minus 5. So I have the derivative. What now?
Are we going to look for the critical number?
Yes. So we want d prime of x to be undefined and d prime of x to be 0 for critical numbers. We always have to analyze both. Good. So d prime to be undefined, it means that x squared minus 5x plus 9 must be 0. For d prime to be 0, it means 2x minus 5 must be 0. So this would be 5/2. And this, b squared minus 4ac, it will be imaginary. So it's always positive. It will never be 0. You can check. We can check real quick. Okay. All we have to do is find the discriminant. Once you find the discriminant and you see it's negative, it cannot have real solutions. And the leading coefficient is positive. So we are looking at 1 and -5 and +9. And it will scream at me, no real roots. Good. So none. So x equals 5/2. I have no idea what this will give. So then x, d prime of x, and d of x. So 0, 5/2, infinity, of course, that's not the case. 0 here. I need the sign below, before 5/2, and I need the sign after 5/2. The first derivative. Which piece of this you will not even bother with, because it's always positive. Of course, the denominator, if that's what you said, this is always positive. Don't even waste your time on it. But 2x minus 5 could be positive or negative. So plug in 0 in it and tell me the sign, and plug in 10 in it and tell me the sign.
Negative and positive.
Correct. So obviously this is typical for a minimum. I can determine it by plugging in the function, this function, plugging in 5/2. I don't know if they ask, but I will ask. So the function is the square root. The function is the square root of x squared minus 5x and +9. And I want to plug in 2.5 or 5/2. And I get that the minimum distance is 1.658. Okay. So coming back to our graph, then I have to determine, because we were asked to find the point that is the closest to this point, and the point that is on the graph of the square root of x, but is the closest to this. So I know the point now. The point is 5/2, comma, the square root of 5/2. This is the point that is the closest to this point, and it finds itself on the square root of x. I don't even care where it is. I don't even need to show. This is the point, so this is the distance. How do we feel about this problem?
Good.
Okay.
Do we always have to find the distance in every question, I guess?
So you said that we're always going to be asked to find the distance?
So I'm asking, like, do I have to always find the distance like you did?
If the problem is asking, yes. That's what I said. Probably this problem is not asking, but I will ask. So like here, we found the minimum volume. The maximum volume. I'm not asked to determine this. I will not ask to determine this, because unless we're asked, find the minimum and the maximum, if you find them. But I will ask to find the distance as well. Anything else? Other questions here? Okay. We'll go back. Good. Here it's asking it's the same idea, but they're asking us to use the calculator because we will not be able to solve probably a certain trig equation without a calculator. That's all it is. And now from this moment on, we get more and more sophisticated. For example, find the area of the largest rectangle that can be inscribed in an ellipse. Okay, so again, so there is a lot of geometry now. A right circular cylinder is inscribed in a cone with height h and base r. That's for the cone. Find the largest possible volume of such a cylinder. So let's think for a moment. Let's just look at the graph and then decide if we want to work on this problem. So I'm just going to draw it and you'll let me know. So in 38, we have a right circular cylinder is inscribed in a cone. So here's the cone. And the cylinder is inscribed inside right here. Okay, and that's the cylinder. And the cone has base radius r, and it has a height of h. Find the largest possible volume of such a cylinder. And we only have h and r. So these are given to us. They're not given to us in form of numbers. So, and when they say when the height is h, it's given to us but no number. And the base radius is given to us but no number. Find the largest possible volume of such a cylinder. So we want to maximize the volume of the cylinder. So in order to find the volume of the cylinder, I have to determine the radius of the cylinder and the height of the cylinder. Because the volume of a cylinder is the area of the base times the height. So I have to name these somehow. So I'm going to call this x, and I'm going to call this y. So the volume of the cylinder is pi x squared times the height. But I can differentiate this function, first of all, because it has two variables. And the second thing is, I have to express x and y in terms of h and r. X and y in terms of h and r. So I promise to give you the idea and let you decide whether you want to, we want to proceed or we want to choose something else. Anything else? Any suggestions, questions? Something happened to Victoria. I hope she's coming back.
I'm okay with moving forward.
I'm good with moving forward.
To a different problem, you mean?
Yes.